Hi learners, welcome. Welcome to Virtual Chemistry. This is Dr. Padmaja. Today we are going to discuss very important problems. Generally, they used to ask you in all types of competitive exams. That's calculation of lattice enthalpy or lattice energy with the help of Born-Haber cycle. So, what topic we are going to discuss? Are you ready, kids? So, it's very important topic. Let's listen carefully, and definitely, I hope you will understand how to do these problems very easily after this video. Okay, now let's start. So what we are doing here, calculation of lattice energy with the help of Born-Haber cycle. Born-Haber cycle. Why we are using Born-Haber cycle? Why can't you calculate lattice energy directly? Do you have any method for that? No, we don't have any method for calculation of lattice energy directly. That's the reason why we use Born-Haber cycle. Let me first tell you briefly what is lattice energy. The energy that is released during the formation of 1 mole of crystal lattice from their corresponding gaseous cations and gaseous ions. For example, if I want to see, in this case is the formation of lithium fluoride. So what are the cations and anions here? Lithium in gaseous state and fluoride in gaseous state should undergo reaction. And during the formation of this lithium fluoride, which is a solid, they will release some energy. That energy is said to be lattice energy or lattice enthalpy. Okay, the definition is the energy released during the formation of 1 mole of solid crystal lattice from their corresponding gaseous cations and gaseous anions. You can give other definition as well. The amount of energy required to break 1 mole of solid crystalline lattice into their corresponding anions, gaseous anions and gaseous anions. You can in both the way it's correct. Okay, now, so what is Born-Haber cycle? Born-Haber is giving the reaction that is taking place in elemental form will be released some heat. That heat is said to be heat of formation of any of the compound. For example, in this case, let's see the Born-Haber cycle, how it looks like. So lithium in elemental form means in solid state reacts with fluorine in gaseous state. How many we want? We want to have 1 mole. So take half fluorine. It has 2 atoms in it. So it is giving lithium fluoride, which is a solid crystalline anionic compound. But this anionic compound is formed from their elemental form of lithium and fluorine, but not from anion and cation. So the energy that is released, in this case is said to be heat of formation. Heat of formation of what? Lithium fluoride. If you want to say lithium fluoride. Now, so we want to have this one. We don't want solid. So let us change lithium from solid to gaseous state. So whenever in any element you want to change from solid to gaseous state, the energy is required. Energy, how to get that energy is said to be what we call as sublimation energy. So it will be always converting from solid to gas. We need a energy. That energy is called sublimation energy. Okay, this is a positive value. Now we don't want lithium. What we want here? Lithium plus. So how can we do that? You have to remove an electron. That process is said to be the energy required to remove an electron is called ionization energy. Always ionization energy value will be positive. Okay, so here lithium in gaseous state is converted into lithium plus ion in gaseous state. So we got lithium plus ion. Okay, now let's go to this element. Well, it is in molecular form. We want to convert into atomic form. So then what you have to do? You have to break the bond here. The energy required to break a bond is called dissociation energy. So dissociation energy, how much we are taking? We are not taking 1 mole. We are taking half mole. So take dissociation energy divided by 2. That is giving fluorine atom in gaseous state. Now fluorine has to be converted into fluoride ion. Here electron has to be accepted by the fluorine. So we should give a plus electron here. So that is said to be the energy released in this process is called electron affinity. Always the first electron when you are adding, energy will be released. That is said to be minus. Okay, it is converted into fluoride. Very simple. So solid to gaseous state conversion requires sublimation energy. Always the system is gaining energy. You have to give positive sign. And if it is system or the reaction is giving energy, then you have to say it's minus. Remember, in this case, where it is gaining, so to convert solid to gaseous state, it is gaining energy, that is sublimation energy. Again, from gas to gaseous ion, Okay, gaseous element to gaseous ion, it is required energy. That is such ionization energy. And dissociation energy is also a positive, it is also gaining. And only electron affinity value is negative. Now, lithium plus fluoride ion together is giving lithium fluoride. So in this case, again, it will release energy. That energy is said to be lattice energy. That energy is called lattice energy. But we have Hess law. What is Hess law? In thermodynamics, we used to study Hess law. According to Hess law, any reaction, if it may takes place in one step or many steps, but the energy required to do that process will be same. Okay, so whether the reaction is following this process, this is first process, this is second process, the energy release must be equal. So let us equate the energy released when the reactants are reacted in elemental form as heat of enthalpy should be negative value. Then add the remaining all energies here, because the energy released in any of these steps should be same. Equate both. So sublimation energy plus ionization energy plus dissociation energy over 2. Next, minus electron affinity minus lattice energy. So this is the equation for this reaction. Okay, so we can use this this equation to calculate what they're asking, lattice energy or lattice enthalpy. So what values they gave you, just substitute and see that the sign of these parameters must be like this. This should be negative. These are all positive, except we want to find the lattice energy anyway. That final value also should be negative because it is releasing. Okay, substitute. So enthalpy of sublimation of solid lithium. Sublimation energy they gave you. How much? Sublimation energy is, where it is sublimation energy? 161. Okay, 161. All are in kilojoules per mole. So don't worry, you can substitute directly. 161 kilojoules per mole. Ionization energy, where it is ionization energy, you see. So ionization energy is 520, so it should be a positive value. Okay, plus dissociation energy should be a positive value. So where is the dissociation energy? You see, bond dissociation energy is 150. And this is for 1 mole, but we want half. So divide by 2. 154 divided by 2 is equal to 77. Substitute 77 directly. Next, electron affinity, how much? They gave 328. Already negative. You substitute negative value only. 328. Okay. Minus lattice energy we want to calculate. And what is the heat of enthalpy? 607, 617. So now calculate and simplify this. Simplify by adding all these values. Then what value you are going to get, tell me. Okay, first add the positive terms here. Minus 617 kilojoules per mole is equal to 6.61 plus 50, 681. 680 plus 70, 758. Okay, 758 minus 328 minus lattice energy. So that equal to 328. If you remove from this, it becomes 430 minus lattice energy. So that means lattice energy is equal to how much you are going to get, minus, calculate and just tell me. It goes 617 minus 430, that equal to 1147 kilojoules per mole. Okay, got this answer? Hope you all got the same answer. So what is the value? Lattice energy is equal to minus, it should be a negative value, remember. This energy is releasing 1147 kilojoules per mole. Isn't it easy? Calculate this. Okay, let us do one more problem on the same concept. And whenever they gave you different units in different parameters, like in kilojoules, instead of kilojoules, if they ask you kilocalories, you need to convert all the units in the same way. But here in this problem, all are in kilojoules. Now let's see what is this equation. Calculate the heat of sublimation of potassium. What they are giving? Potassium chloride. Okay, let's write Born-Haber cycle for this. In elemental form, potassium in solid state and half chlorine gas is reacting and forming 1 mole of potassium chloride, which is a solid, and the heat that is released in this process is called heat of formation of potassium chloride. Now, in order to get lattice energy, first you have to change them into ionic gaseous ions. Now let's see. How can we change? We can't change directly. First, potassium from solid to potassium into gaseous state, we have to convert. So when it is going from solid to gaseous state, the energy will be really required. So that is said to be sublimation energy. And from this to ionic state, so loss of electron, this is said to be the energy required is a positive energy, that is ionization energy. So again it is gas. We got cation, gaseous cation. Now we need to convert this also into gaseous anion, right? Already it is a gas. The only thing you need to have, it is a molecule you have to break up, and it's said to be energy required for that process is called dissociation energy. So it is a positive value. Molecule will gain energy to when it is undergoing break. Okay. So what we are going to get? Chlorine gas element, and it has to be converted into Cl minus ion. In this process, if you see, gas is converting into a negative ion, means we are adding an electron. So when you add an electron, first electron, it will be releasing energy that is called electron affinity. So it is a negative value. Now you see these two together reacting and forming potassium chloride. This is one step that is Born-Haber gave. This is the second step that we know. During the formation of this, lattice energy will be, the energy that is released is called lattice energy. Okay, fine. Now let us calculate to this problem. Write equation first. Write the equation. Energy released in this process. Heat of formation of is equal to what parameters we have to do. So why we are equating here? According to Hess law, whether the reaction takes place in elemental form or in gaseous cation anion combination, it doesn't matter. In both the cases, the energy released will be same. That's why we are equating these two. In the first, we took elemental form, that is, energy released is called heat of formation, is a negative value. And the second step, sublimation energy plus ionization energy plus dissociation energy by 2, then minus electron affinity minus lattice energy. This is one process. We took here two processes. This whole cycle is said to be Born-Haber cycle. Now in this case, if you see, they gave you values here. Just substitute those values in this equation and any parameter can calculate. So here what they are asking is the following information to calculate the heat of sublimation of potassium. This thing you have to find. Okay, substitute the rest of the values. Heat of formation they gave you negative, always it should be negative. See that if they gave positive also you have to take negative. And use units kilojoules per mole. Then electron affinity. Okay, first see the ionization energy, that is positive 418 plus dissociation energy, bond dissociation energy 240. See that is 121.5. So 121.5. And electron affinity value minus 349. So this is just sign. This don't substitute minus of minus plus. It's a sign of releasing. Okay, and lattice energy should be negative. If they gave negative, also take as this, or else you can take negative value. So lattice energy, how much they gave? 107. Okay, now simplify this and find what is sublimation energy. You simplify this, what you are going to get? Just try to simplify this and the value. Okay, minus, I'm writing here, minus 437, leave it like that. Add the positive terms this side, plus, okay, 480 plus 121 is 539.5. 539.5 minus 700 plus 300,000, 1049, 1049 plus 20, 1049, 50, 66, 1066. Okay, now remove this is 300, okay, 391.590.5. Okay. So if you simplify this, finally you are going to get the sublimation energy 591,066 minus 599. How much you are going to get? Just tell me the final value. And finally you are going to get the value, that is 89.5 kilojoules per mole. Hope you did this one. Okay. Let us do one more last problem in the same type. Okay, using Born-Haber cycle. So now you just try to do this without seeing this video. Just pause the video and try to do this problem. Okay, now I'm going to write Born-Haber cycle here. And what is here? Calcium fluoride. Okay. Calcium in elemental form means solid metal, and fluorine is gas. 1 mole of fluorine we need, and 1 mole of calcium fluoride is forming. During this formation, the heat released is called heat of enthalpy of formation of calcium fluoride. Okay, this should be a negative value. Now write Born-Haber cycle for this. First, it has to be converted into gas. So here it needs energy, which is called sublimation energy. Then it's a positive value. Then it has to lose first 1 electron. So what is the ionic equation? Calcium 2 plus 2F minus is converting to calcium fluoride, and the energy released in this case is called lattice energy. Okay, we want this equation. That means first it has to lose 2 electrons. We can't remove at a time 2 electrons. So it will lose first electron. That is, sorry. Okay. Now first ionization energy is a positive value, that is converting into calcium to calcium plus. Again, 1 more electron it has to lose to convert into calcium 2 plus. This is called second ionization energy. This is also a positive value. Now here we have fluorine molecule that has to be converted into independent atoms. That means you need to break the bond. The energy required here is called dissociation energy. It's 1 mole we are taking, so directly take dissociation energy. We are going to take 2 fluorines. But we don't, we need fluoride ions, not fluorine. So it is in gaseous state. It has to convert it into fluoride ion, 2 fluoride ions. So minus electron affinity multiplied by 2. Because 2 independent atoms are involved in here. Energy will be released when electron is added. And here electron is removed, first electron, second electron. Now calcium plus fluoride will give you calcium fluoride in their gaseous state, gaseous atomic state, gaseous anion and gaseous cation. The energy released here is said to be, what we call it as? We call lattice energy. It is a negative value. Now you see the energy that are released plus sublimation energy plus ionization energy 1, second ionization energy, dissociation energy, electron affinity times 2. Why? Because 2 fluorines for each fluorine minus electron affinity. 2 fluorines we have, so that's why I took 2. Now let us write equation first. Use Hess law and equate both the parameter. According to Hess law, whether the reaction takes place either in this way or in this way, the energy released in both the cases are same. So let's say equate both. In this case, the energy released is called heat of formation of calcium fluoride. That is equal to how much energy is involved in this. We need to add all those things. Okay, take in this case sublimation energy plus first ionization energy plus second ionization energy, next plus dissociation energy minus 2 times electron affinity, next minus lattice energy. This is the whole equation. Now substitute the values in this equation. Substitute the values in this equation. I'll write together minus lattice energy. Now substitute. What they are asking you to find, calculate the second ionization energy. This thing you need to find. Okay, let us substitute. First one, heat of formation of calcium chloride. Where it is? See, heat of formation is minus, already they give, minus only you take 1215 kilojoules per mole. Okay, that equal to sublimation energy. Where is sublimation energy? You see, that is 178.2 kilojoules per mole. Next, what is the first ionization energy? The positive value, that is 589.8 kilojoules per mole. Next, so you need to find second ionization energy. Okay, I will write down. Okay, plus next, dissociation energy. Bond dissociation energy is 158 kilojoules per mole. Okay, next, it's a positive, no, it's a negative. Negative 2 times, what is the electron affinity value you take? Minus, already I wrote 328. 328 times 2 you have to do. Next, what else we have to write here? Plus ionization energy. Minus lattice energy. What is the lattice energy? Minus lattice energy is 2630. 2630. Okay, try to simplify the terms, all of these terms. Minus 1215 kilojoules per mole is equal to, add all positive terms and add all negative terms. What value are going to get? Please try to tell me. So ionization energy, second ionization energy, plus what are the positive values? If you add together, you are going to get 926 kilojoules per mole. Next, negative values, 3286 kilojoules per mole. Okay. And you simplify furtherly, that will become, this value will become 2326. So that equal to ionization, second ionization energy minus 2360 kilojoules per mole. Okay, take this value to that side and find the final. So ionization energy is equal to 2360 minus 1215, that equal to 1145 kilojoules per mole. Kilojoules per mole, this is the answer. So what is the second ionization energy value? This much. Okay. So in this way, they may ask you any of the parameter by giving the remaining. So you can do easily if you know how to write Born-Haber cycle. So thank you for watching. If you like my video, please subscribe, share to your friends. Thank you. Bye. See you in the next video.